Hello everyone, today I would like to teach you another method to solve simultaneous linear equations in two unknowns. This method is called the elimination method. Let me bring you an example from our daily life to show you how this works. In a gift shop, we see Tanjiro figures and Nezuko figures. They are sold in sets. 5 Tanjiros and 2 Nezukos are sold at $300. Another set is 3 Tanjiros and 2 Nezukos, which is $200. But I don't need that many figures. I just need 1 Tanjiro and 1 Nezuko. I wonder if we can calculate how much does each one cost. Comparing the two sets above, you can see that most of the things are actually the same. It's just that the first set has 2 extra Tanjiros. And so we can have a conclusion. How much are these 2 extra Tanjiros? It is the difference between these two sets, which is $100. And so 1 Tanjiro is $50. And so if we know that 1 Tanjiro is 50, then put it back 3 of them would equal to $150. 150 plus 2 Nezukos is $200. Moving 150 to the right and solving this equation, 1 Nezuko costs $25. This daily life example uses the elimination method. In this example, we make Tanjiro as x and Nezuko as y. This is a set of simultaneous linear equations. How do we write this in our exams? It is quite similar to the method we learned previously. We first label the two equations. We label them as 1 and 2. Before we do elimination, we must do something first. Because we are doing addition and subtraction, we must ensure that the terms are aligned with each other. Aligned meaning x is to x, y is to y, numbers to numbers. After being aligned, now it's easier to do addition and subtraction. In the previous example, what was extra were the 2 Tanjiros from the 2 equations. What does this mean for this equation? This means we are subtracting 2 from the first equation. Subtracting the 2, 5x minus 3x is 2x, 2y minus 2y, there's nothing left, so at last we have 2x equals 100. And so x equals to 50. Now we put back the x answer into one of the equations. In here we choose equation number 2. Plugging in the 50, after doing some operations, we get y equals to 25. Finally, we write down our answer, and that is it. If you are in doubt of your answer, all you need to do is plug in back x equals 50 and y equals 25 back into the original equation. If x equals to 50 and y equals 25, plugging it back into this equation, we still get 300. And the equation at the bottom, if we also get 200, then for sure our answer is correct. For the elimination method, is it always the first equation minus the second equation? Actually not. For the elimination method, sometimes we would add the equations together, not just subtract. Let's look at the following equation. The first step is to first label the two equations. The second step, we check if they are aligned with each other. And now we can see that x, y, and the numbers are all aligned. And now we look at these two equations and we think about whether adding them together or subtracting them together would eliminate one of the variables. Within these two equations, we can see that 5y is the same. However, we cannot just look at the 5y. We also have to look at the sign in front of 5y. How do we eliminate plus 5y and minus 5y? If we could add the two equations together, that would be perfect. 1 plus and 1 minus, adding them together, that would be 0. And so, adding the two equations together, we get 5x equals to 20. And the y term, because of adding them up together, is now eliminated. We end up with x equals 4. And now we put x equals 4 into one of the equations. We choose equation number 2. We plug in the numbers. After some more operations and calculation, we get y equals to 2. Writing down the solution, and now this question is complete. You could always put back this solution back into the original equation to double check if you are correct. One last example. This is our simultaneous linear equations in two unknowns. The way we do it is the same each time. We first label the two equations. Then we check if the two equations are both aligned. We see that the x, the y, and the numbers are all aligned. And now we look at these two equations. Can we eliminate any variables? If we add them up together, 6x and 3x equals to 9x. 5y plus negative 2y equals to 3y. Same with the numbers, and we realize adding them up together cannot eliminate any variable. If we subtract the two equations, we end up with 3x plus 7y equals 22. Take note that in subtraction, negative times negative is positive. After subtraction, we find that there are still two variables in each equation. This means no matter if we do addition or subtraction, we still cannot eliminate any variables. So how do we calculate? This time we cannot immediately do elimination. We need to fix one of the equations. How do we do it? We first multiply the second equation by 2. Remember, we need to multiply the whole equation by 2. This means 3x becomes 6x, 2y becomes 4y, negative 5, negative 10. We double the entire equation. After multiplying by 2, we realize that the x terms are exactly the same. And now we can see that the first equation, and also with this new equation, we now label this as 3. By doing elimination now, we can take away the x variable. Because the number of x's are the same, so all we need to do is a subtraction. Remember, it is not 1 minus 2, it's 1 minus 3. Subtracting the two equations, 6x minus 6x is 0, 5y minus negative 4y is 9y. The numbers are the same as well. 17 minus negative 10 is 27. And finally, after some calculation, y equals to 3. We are not yet finished. We still need to calculate x. We put in y equals to 3 into any of these two equations, then we can find x. This time we choose the first equation, which is 6x plus 5 times 3 equals 17. After some simple calculations, we get x equals to 1 over 3. Writing down the solution, now we are finished. Sometimes students may doubt themselves, thinking, oh, my answer is a fraction, but not a whole number. Is it correct? Again, if you are in doubt of your answer, you can always put back your solution into the original equation to check. Then you would know whether you are actually correct or not. That's the end of today's video. If you have any more questions, feel free to go to the maths room and ask your teachers. Goodbye!